Now we're going to look at how we're going to calculate the density of an unknown liquid. First, we need to determine the volume of our flask. So we're going to start by measuring an empty flask with its stopper. And so this is a measurement we're going to take. It's not calculated. And we'll write down every digit the balance gives us. Be sure every time you write down a number, you include the units. Okay. Then we're going to fill our flask with water all the way to the top, and we'll take its mass again. So again, this is a measurement. And let's just say I get this. I wrote down every digit that the balance gave me, but notice I didn't get as many digits as I did before. And that's because sometimes when this mass is higher, you'll get fewer digits past the decimal. Okay, next I'm going to determine the mass of the water, so I'm just going to subtract. Okay, and I'm going to follow my significant figures rule for adding and subtracting. I look at how far they go past the decimal. I do not count sig figs. So the top number only goes 2 past the decimal. That means my answer can only go 2 past the decimal. Okay, so my answer for the mass of water with the correct sig figs is this. Okay, but notice that I really have an extra digit there, even though it doesn't count for sig figs. If I want to use this number later on, I might want to go ahead and use that number and just keep track of the fact that this is the last sig fig here, the 9. That way we're not rounding until the very end. We're not rounding with a lot of different steps and accumulating error. But anyway, if I write an answer over here on an answer line, I need to round it off to the correct sig figs, even though I might be kind of keeping track of some extra digits as I go. Okay. Next, I'm going to take that mass of water and get a volume of water. And to do that, I need to get a density. In your lab manual, it gives you the density of water at different temperatures. So this one, I'm going to use, let's see, one more digit. So this is the density of water is given. Okay, so let's see how we're going to use that. I know the grams of water, so I'll put that here. Oh, and again, if I want to, I can use the more digits that I have, even though I know that that's the last one that's significant. I'm setting this up as a conversion factor type problem, and I'll show you why in a second. I've got grams up here, so I want grams down here. And I'm trying to get to milliliters, which is the volume, milliliters. And then in this spot, I'm going to use the density. The density is this 0.9982. And that's per 1 milliliter.